Hello kids. So I hope that you have revised the questions from first question number 1 to 5 and you have practiced them at home well. So now let us start with the next question, that is question number 6 here. The numbers 13 and 31 both are prime numbers. Both these numbers have same digits 1 and 3. Yeah. So we see here 13 and 31 they are using the same digits 1 and 3 and both the numbers are prime numbers. We have to find such pair of prime numbers up to 100. So starting from 1 till 100 we have to find such pairs where the two prime numbers are reverse of each other. Okay, like 13 and 31. So let's try and find it out. First is we have to find these pairs of number. So starting here with 13 is given to us. Now let's start 2. What is the reverse of 2? The reverse of 2 is, you can take it as 20, but both of them, they are not the prime numbers. 20 is not a prime number. Okay, so now similarly 30, 50, 70 is not a prime number. 11, the opposite of 11 is 11, again not. So the first one is 13 and 31, which is given to us. Next we have 17. 17 is a prime number. The opposite of 17, if we reverse the digits, we will get 71. And we see 71 is also a prime number, right? 19 is there, is a prime number, but 91 is not prime. So we have to skip this. 23 is prime, but 32 is composite. 29 is prime, but 92 is again composite number because both are even numbers. 31 we have already taken. Now 37, we have 37 and 73. So 37 is a prime number and you see 73 also is a prime number. So this is one such another pair. Next, we have 41 but 14 is not. 43 but 34 is not because it's again a composite number. 47 and 74, 74 is even, so it's the composite, so it's not possible. 53, opposite of 53 is 35, which is a composite number. Now, we have 59, opposite of 59 is 95, which is divisible by 5. So it's a composite number again. 61, opposite is 16, not possible. This is also not possible because opposite is 76, which is even and composite. 71 we have taken, 73 we have taken, 79. 79 is the prime number and opposite is 97, which is again a prime number. So we can also write it. Next, we have 83. Opposite is 38, which is again even, so it's composite. 89, opposite is 98, which is again, it's a composite number. So these are the possible pairs where both the numbers, the number and the reverse of the number, both are prime numbers, right? Next is answer 7. We'll do here. Find 7 consecutive composite numbers between 1 and 100. So again we can use this and we have to find a list of 7 consecutive composite numbers which are there between 1 and 100. So everywhere kids you see the maximum 5 are there. Here also 1, 2, 3, 4, 5. Okay. And the maximum which we have already seen in question number 2 is here. So this is starting from 90, 91, 92, 93, 94, 95 and 96. These are 1, 2, 3, 4, 5, 6, 7. 7 consecutive composite numbers, right? This we can easily find out from the table given to us. Next we have a concept of twin primes. So what are twin primes? They are pair of primes having a difference of 2. Example 3 and 5. We know 3 and 5 are prime numbers, right? And the difference in these prime numbers, that is 5 minus 3, will give us 2. So if I'm writing here, if difference in two prime numbers is 2, They are called twin primes, right? So this is called as twin prime. Example is 3 and 5. Okay, two prime numbers and the difference is 2. They are called as twin prime numbers, twin primes. Now, so are 17 and 19. Another example is 17 and 19 because there also the difference between them is 2 here. Find the other twin primes between 1 and 100. So let's try to find out more using this diagram. What we have here, we have already marked 3 and 5. Next, kids, we can see 5 and 7. There is again a difference of 2. So I'm writing 5 and I'm starting from here, 5 and 7 here. Then 11 and 13 next. Okay, and then 17 and 19 already marked. Next, we can see from here 41 and 43. 41 and 43. 71 and 73. That's all. So these all are the twin primes starting from 1 to 100, where both the numbers are prime and the difference between them is 2. Right? Everywhere you will see here the difference will be 2. So they are twin primes. Next is identify whether each of the statement is true or false. Let's see. There is no prime number whose digit unit is 4. So what they are saying is that there is no prime number whose unit digit is 4. Example here is 14, 24, 114 and all. So they are saying that if there is the unit digit, if we have 4, it cannot be a prime number, which is true. Why? Because if 4 is present, then that number will always have 2 as one of its factors. It will always be a multiple of 2. So since 2 will be a factor, it cannot be a prime number, right? Next, a product of prime can also be prime. So what they are saying is that a product of prime can also be a prime. So kids, this is not possible because the concept of prime is itself that number, that it has only two factors, that is 1 and the number itself. Example, I am taking 3 here. So 3 has 1 and 3. Okay, and 1 is neither a prime number nor a composite number. Let's say if I take another prime number, that is 2, and multiply it with 3. So now both are prime numbers and I'm taking their product. Answer I'll get is 6. But 6 is not a prime number. Why? Because it has 2 and 3 as its factors. The number of factors are more, so it cannot be a prime number. This is false statement. Prime numbers do not have any factors. This is also false because it always have two factors and they are 1 and the number itself. It always has two factors. Itself. All even numbers are composite numbers. So all even numbers are composite numbers. So this is false. Why? Because 2 is a even number and it is prime. False. Why? 2 is even and prime. Except 2, it is false. It is true. If the statement would have been like all even numbers are composite numbers except 2, then we should have written true here. But since they have not excluded 2, so it will be a false statement. Next is 2 is a prime and so is the next number 3. For every other prime, the next number is composite. Okay, so what they are saying is that example, let's take an example from 1 to 100 only. What they are saying is 2 is a prime and the next one is also prime. Okay, but except these two, except 2 and 3, or everywhere, for every other prime, the next number is composite. So let's see here. For 5, it's a composite, true. 7 also, 11 also. So in this chart, if you see everywhere except 2 and 3, there are no two consecutive prime numbers. So this statement is true. Okay. Now, let us move to the next part. That is question number 10 here. So here, which of the following number is the product of exactly three distinct prime numbers? So kids, let us understand this question first. What we need here is we have to identify that which of these numbers given to us, they are product. That is, they are find out by multiplying three distinct as in three different prime numbers. Okay, so let us find their factors. I'm writing the numbers here. First we have 45, 60, 90, 105, 330. So for 5 it is 3 and again 3 and 5. So we have only two prime numbers. Okay, we don't have three distinct prime numbers because 3 is repeated. So this is not the number we want. So here for 60, what are the different factors? For 60 we have 2 and then again 2, 3 and 5. Okay, so we have three distinct numbers, but we have three numbers, but this one is again repeated. This is repeated, that is okay, but still we have three distinct numbers, so we can take 60 here. Okay, next one we have 91. So the factors of 91, we have 13 and 7, which are two factors. So we cannot take this. We have to ignore this because we need exactly three distinct ones. Next we have 105. So for 105, the various factors we have here are 5 first of all, then 3 and 7. So kids, again it has exactly three distinct prime numbers. Last one we have 330. So how we can write down 330? We have 3, then we have 11 and 2 and 5. So since we need exactly 3 and we have 4 distinct numbers, so we will discard this. So the answer here we will write 60 and 105. Okay. Now let's move to question number 10. So next question 11 here is, how many 3-digit prime numbers can you make using each 2, 4 and 5 ones? So we are given 3 digits 2, 4 and 5, and we have to make different arrangements of these numbers, and we have to find out that how many 3-digit prime numbers we can make. Okay, so let's start with 2. I will keep 2 as is and I will write 4 and 5 in this manner. So we have 245, which is divisible by 5. That means apart from 1 and 245, we have 5 also as one of its factors. So it is not prime. Okay, why? Because it is divisible by 5. So I'm writing 5 is also a factor. So it is not a prime number. Next, again I'll keep this 2 as is and I will shuffle these numbers. So we will get 54. Now for this 54, since 4 we have, which is even number, 2 is also a factor. It will be divisible by 2. 2 will be one of its factor. So again, this is not a prime number. Next, I will take 4 ahead and I will write 25 for 425, which is again a multiple of 5. So 5 is one of its factor. It is again not a prime number. Again 4 like this, and then I will shuffle 2 and 5. So this is 452 and 2 is a factor of this. So again it is not a prime number. Last we have 5. So I'm writing 5, then 2 and 4. So 4 is here. That means 2 is a factor. 2 is a factor. So it's not a prime number. Last 542. I'm shuffling these two. That means again 2 is a factor of this. So It is not a prime number. So using these three numbers, we cannot make any 3-digit prime number. Okay, so no number is possible. Sorry, I should write no 3-digit prime number is possible using 2, 4 and 5. Okay, I hope this is clear what we have done. We have picked one number and then we have used two number and then we have changed the arrangement, right? So with using these three number in different arrangements, we have seen that all the numbers are either a multiple of 2 or 5. So they are all non-prime numbers. So we cannot make any 3-digit prime numbers using these three numbers. Next, we have here is observe that 3 is a prime number and 2 multiplied by 3 and adding 1 to it will give us 7, which is also a prime. Are there any other numbers? Answer 12. Are there any other prime numbers for which doubling and adding 1 give us another prime? Write down at least 5 such examples. So, what is given here is we have taken a prime number example which is given to us. We have taken a prime number and we have doubled the number. That means we have multiplied it by 2 and then adding 1. We have added 1 to it. We took 3, we doubled the number, we added 1 to it. And the number it is generating is again a prime number. That is 3 multiplied by 2 is 6 plus 1, 7, which is a prime number. Now, we have to identify more prime numbers which on doubling or adding 1 are giving us another prime numbers. Let us start with 2. So, we have 2. We multiply 2 with 2 and add 1 to it, which is giving us 5, which is a prime number. Okay, so 3 is one example, 2 is one example. Now let us pick 5. Let us multiply 5. 5 is a prime number. We are doubling it and we are adding 1 to it. So it is giving us 11. So kids, 11 is also a prime number. So we can take this example also. Next, we have 7. We will multiply 7 with 2 and add 1 to it. Doubled and added. It is giving us 15, but 15 is not a prime number. So we cannot take 7, right? And after 7, what is the next prime number here? We have 11 as the prime number. 11 multiplied by 2, adding 1 to it. So it is giving us 22 plus 1, 23. 23 is a prime number. Okay. And after 11, we have 13. So 13 is multiplied by 2, doubled, adding 1 to it. It is giving us 27. But 27 is not a prime number. Okay, it has factors. It has 3 as one of its factors. Okay, so we cannot take 13. Next, we have 17. So 17 multiplied by 2 plus 1. 17 multiplied by 2 will give us 34. 34 plus 1 is 35. But 35 is again not a prime number. Right? Next, we have, after 17, we have 19. So, if I take 19 here and I multiply by 2 and add 1 to it, so 19 multiplied by 2 will give me 38 plus 1, 39. But again, 39 is not a prime number. We have identified 4. We need one more prime number. Next is 23. Let's multiply 23 with 2 and add 1 to it. So this is 2, 3, 6, 46 plus 1, 47. 47 is a prime number. Okay. So the 3 examples of such prime numbers where we can double and add 1 to it and we are getting another prime number are 2, 3, 5, 11 and 23. Okay. Rest of these are not. Why? Because we are getting, when we are doubling and adding, we are getting a composite numbers, and primes we are getting only for these. Okay, so this is the end of this exercise, kids, and I will see you all in the next class with the next concept of co-prime numbers. Okay, so I will see you all in the next class now. Thank you.